Introduction to isothermal process. As the air bubbles rise to the surface of the water, the volume of the bubbles increases. If the temperature of the water is constant, the air in the bubbles is said to undergo isothermal expansion. In this lesson, you will be able to define isothermal process, state the conditions for isothermal process of a gas, use the equation PV equals constant, sketch the PV graph to represent isothermal process, derive the expression for work done in an isothermal process, use the first law of thermodynamics to explain isothermal process, and show how isothermal process is carried out in practice. Click on the gas in the cylinder and observe the expansion of the gas when heat is being supplied. What do you observe about the temperature of the gas? Answer: the temperature of the gas remains unchanged during the process. The gas is said to undergo an isothermal expansion. During an isothermal process, the temperature of the gas remains constant. The relationship between the pressure P and the volume V of a gas during isothermal changes can be derived from the ideal gas equation. The volume of a gas in a cylinder fitted with a smooth piston is V when the pressure is P. Click on different values of the volume to change the volume of the gas at constant temperature. Observe how the pressure of the gas in the cylinder varies. Click to select the temperature of the gas and observe how the pressure of a fixed mass of gas varies with its volume when the gas expands isothermally. Each of these curves is known as an isotherm. The change in the pressure of a gas during an isothermal expansion can be explained using the kinetic theory of gases. Click play and observe the isothermal expansion of the gas. Select the changes, if any, in the table and then deduce the change in the pressure of the gas. Similarly, the change in the pressure of a gas during an isothermal compression can be explained using the kinetic theory of gases. Click play and observe the isothermal compression of the gas. Select the changes, if any, in the table and deduce the change in the pressure of the gas. Summary. An isothermal process is the change of pressure and volume of a gas at constant temperature. An isothermal process obeys Boyle's law, PV equals constant. The PV graph of the isothermal process is known as isotherm. Click on the piston and observe the area under the pressure-volume graph, which represents the work done by the gas during isothermal expansion. Click on the piston and observe the area under the pressure-volume graph, which represents the work done on the gas during isothermal compression. When a gas expands isothermally at a temperature T from the initial volume of V1 to the final volume V2, the area under the PV graph represents the work done by the gas. An expression for the work done by the gas can be deduced as follows. When a gas is compressed isothermally at a temperature T from the initial volume of V1 to the final volume V2, V2 less than V1, the area under the PV graph represents the work done on the gas. Since V2 is smaller than V1, therefore the work done has a negative value. Summary. Area under the PV graph represents the work done in an isothermal process. The expression for the work done in an isothermal process is given by W equals nRT times ln of V2 over V1. When a gas is compressed isothermally, final volume V2 is smaller than V1, and therefore the value of the work done is negative. The first law of thermodynamics can be used to explain the energy required by a gas to do work when it undergoes isothermal expansion. Click Isothermal Compression to observe what happens during the process. Select from the appropriate boxes the changes to the following thermodynamic quantities. Click on the part of the graph which corresponds to each of the processes shown in the table. Click on the part of the graph which relates to the internal energy of the gas as shown in the table. Click on the part of the graph which corresponds to each of the processes shown in the table. Summary. Heat is absorbed by the gas for it to do work during an isothermal expansion. Since the temperature remains unchanged, the internal energy of the gas remains constant. From the first law of thermodynamics, since delta U equals 0, Q equals W. For isothermal compression, since the internal energy of the gas remains constant, the work done on the gas is dissipated as heat.